Lesson 2-7 is on parent functions and transformations. A parent function is the basic form of a particular type of function. And you're familiar with all of these, you probably just haven't seen it written this way before. A constant function is a function f of x equals a, where a is any number. The identity function is f of x equals x. In other words, x and y are identical, they are the same thing. The absolute value function, where f of x is equal to the absolute value of x. And the quadratic function, where f of x is equal to x squared. So here's what they look like. Constant function y equals some number is a horizontal line. The identity function y equals x is a perfectly diagonal line through the origin and through the points 1, 1, 2, 2, 3, 3, 4, 4, and so on. The absolute value function, which we saw in the last section, is basically a graph of a v, and the absolute value has its vertex. The parent function of absolute value has its vertex at 0, 0, and it goes through 1, 1, 2, 2, 3, 3, but also negative 1, 1, negative 2, 2, and so on. And the quadratic function, y equals x squared, if you remember this from Algebra 1, our basic parabola. Now, just like in geometry, we can do transformations on these graphs. And remember, transformations in geometry were where we moved some of the shapes around. A translation, we can move it up or down, right or left. A reflection, we can flip it over the x or the y axis. And a dilation, we can enlarge it or shrink it proportionally. The one that we're not doing is a rotation. That's a little more complicated. There's a chart in your text on transformations of functions. Looks like this. Looks a little complicated. You can refer to that if you like, but the way we are going to do transformations is I'm going to ask you to graph, and here we're going to do several, I think we've got 7 quadratic functions here. I'm going to ask you to graph the function on your calculator, copy it onto graph paper, and then describe this transformation. How does this change from the original parent function? So let's do a couple of these together. So y equals x squared minus 2. So here on my calculator, I have in y2, I have the parent function. Actually, we can look at it over here. I've decided to graph the parent function, y equals x squared, in y2. And I'm going to go ahead and graph the one that we need to do, x squared minus 2, in y1. So x squared minus 2. Okay. Now, when I hit graph, what I'll see is the red line is my parent function. Okay, you can refer back over here. The red parabola is y equals x squared, and then the blue one is y equals x squared minus 2. In the homework for tonight, what I want you to do is actually graph the blue line on a piece of graph paper. Go ahead and make the table and do the graph. But for here, all I need to do is describe what's going on. So this is actually, the blue line is actually the graph of y equals x squared translated down 2 units. So this is the graph y equals x squared, and it's translated down 2 units. So you notice that this minus 2 actually moves it down 2. Thinking about that, what do you think number 2 is going to do here? Y equals x squared plus 6. Let's take a look at that. So I will go over here, and instead of minus 2, I will do a plus 6 and graph that. And remember the red, it's not graphing the red one. Oh, there we go, there's the red one. The red is my parent function, and the blue line is x squared plus 6. It's not showing up quite right here, but that's okay. X squared plus 6, and this is the parent function translated up 6. Up 6 units. Okay. For my third example, now notice there's a plus 1, but in this case it's in the parentheses. So y equals the quantity x plus 1 squared. So that's probably not going to move it up. Let's see what happens when we do that. I'll just start over here. So I need parentheses, x plus 1, close parentheses, and square that. And let's see what happens when we graph. There's the quantity x squared plus 1, x plus 1 squared, and the red is my original parent function. Okay, so this looks like it's the parent function translated 1 unit to the left. So this is y equals x squared translated left 1 unit. Okay, notice that's kind of interesting because left we tend to think of as being negative, but in this case it's a positive, x plus 1. So what do you think is going to happen with this one? Y equals x minus 4 quantity squared. Chances are this one's going to be translated 4 units to the right. But let's confirm that by taking a look at this. Parentheses x minus 4 squared. And we will graph that. And there's x minus 4 quantity squared, and there's my parent graph. So indeed, the translation is 4 units to the right. So it's my parent graph, y equals x squared, translated right 4 units. Okay. So whether or not the plus or minus a number is outside the x squared or inside the parentheses determines which way it moves. Okay, let's take a look at number 5. Y equals negative x squared. So a negative x squared. Let's take a look at that graph. So there's negative x squared, and there's my parent graph of y equals x squared. And this appears to be the parent graph, the red one, reflected over the x-axis. So this is the graph of y equals x squared reflected over the x-axis. Okay, notice that's what the negative out front does to it. Let's try number 6. Y equals 3x squared. 3x squared. I'll graph that. And my parent graph is in the red. 3x squared is in the blue. So this is actually compressed. It's kind of like we took the red graph and we kind of squeezed it in towards the y-axis. So this is the graph of y equals x squared compressed. And what did that is the coefficient of 3 out in front. Okay, now let's try number 7. Let's see what a 1/5 out in front of the x squared does. So you can either do this as a fraction in parentheses, or if you want to convert it to a decimal, you can do that. Okay, and let's see what that looks like. Y equals 1/5 x squared. Sure seems to widen that out quite a bit, but let's compare it to our parent graph coming in the red. Yeah, and this is my parent graph expanded, kind of spread out quite a bit. So this is y equals x squared expanded. Okay, so you can see how putting a number in front, or a negative sign, or adding a number inside or outside the parentheses transforms the parent graph of y equals x squared in several different ways. So for the homework tonight, I want you to do numbers 10 through 13 all, and these problems here. In fact, these are very similar to the ones that we just did. I did it with the quadratic parent graph. These you'll be doing with the absolute value parent graph. And remember, you can get the absolute value in your calculator by going to the math menu, the number submenu, and the first one is ABS. So graph those on your calculator, copy the table into your homework, and then graph it, graph the transformation, and describe it for me just as we did with the quadratic functions.